In this lesson, we'll talk about big idea number 1 and number 2. So how are organic compounds classified, and how does their structure determine their properties? We'll discuss polymers, learning target number 4. So by the end of this lesson, you should be able to describe how a polymer structure determines its properties and its use, and also explain the different types of monomers and reactions that are used to make a polymer. Polymers are very long molecules made up of small repeating units called monomers. Polymers occur in nature, or they can be manufactured in a lab to fulfill a particular purpose. Polymers that can be heated and molded are called plastics. Polymers are classified based on which type of reaction is used to join the monomers together. There are two main types. The first being an addition polymer. Monomers with double bonds are joined together using an addition reaction. The simplest example is polyethylene. It's made by joining the monomer ethene together. Because I'm doing an addition reaction, the double bond will be broken and changed into a single bond on both of the monomers. That means that each of the carbons in the ethenes will be one bond short and looking for something to bond with. If only ethene is in the beaker, they will bond to each other. Now the two carbons at the ends only have 3 bonds. This was created when the double bonds on the ethene was broken. They have an active site where another ethene can break its double bond and join on and extend the chain. The chain can be as long as you want, as long as you continually supply ethanes to it. When you want the chain to finish, you bubble in hydrogen gas, which would then bond onto the end carbons and complete your chain and make all of your carbons stable. For more examples of addition polymers, look on page 118 of your textbook on table 2.1. Condensation reactions can also be used to make polymers. Monomers are joined together by either making ester or amide bonds. These monomers must have 2 functional groups at either end to make the chain continue. Polymers using ester linkages are known as polyesters. They use diacid and dialcohol monomers. For example, if I have a 1,2-ethane-diol, I would have the hydroxyl groups at either end of the chain. And then in order to make it an ester, I would use a 1,2-ethane-dioic acid. Again, with the functional groups at either end of the chain. Because I'm doing a condensation reaction, I have to release water as my second product. Notice that my product has a hydroxyl group on one end, which could then react with another diacid monomer to extend the chain. And at the other end, it has a carboxyl functional group, which could then react with another dialcohol to extend the chain in that direction. As long as I supply my polymer with both monomers, they will be reacted in alternating orientations until one of the monomers runs out. Now, condensation polymers can be made with just one monomer. We could make a polyester if we had a monomer that had a carboxyl group on one side and a hydroxyl group on the other. Then we would take that one monomer and repeat it over and over and over again, making many ester linkages. Now, polymers using amide linkages are called nylon or polyamides. They often use diacid and diamine monomers. An example is nylon 66. Check out the video that I've posted on the website. For more examples of polymers, look at table 2.2 on page 120 to see the structures.